V for view, new view, mark 1, clicky clicks off, define your window from the endpoint here to the endpoint there, enter to accept, OK, apply, OK, and now if you say V for view, mark 1, set current, OK, it will jump right to that. If you say V for view, you will also then start to see what I talked about in class, and that this is just defined by a vector of a direction vector. The width and the height do not look correct. They do not look correct. So we want to go back and check what we grabbed, because if you see the width and the height, it should have been 70 and 90 or something like that. So we're going to come back here and hit cancel. We can now, perhaps we don't need that image anymore, so we can go into our layer manager and turn off the images and realize we didn't put that view layer. We're going to do an undo here. There's my box. Let's see what our view is. V for view, mark 1, edit boundaries. And it should be correct if I made that box correct. And so if I then look at the definition of the vector of the, I'm sorry, I read that wrong. It was the roll angle I read incorrectly. I apologize. You see here that you have a 70 and a 90 for a height and a width, which makes sense for when you make your view. When I point out the view, I want to point out the camera has a vector position and the target has a vector position. This is a unit vector in this case. We'll be talking about unit vectors. It then also has a roll angle. When you get into perspective views or 3D views, it will look a little different, but the fundamentals are the same. If you want to really see how cool views can be, the program to download at home or look at on the Apple or whatever I've got in school is a program called Photosynth. It will rock your world. You haven't been to Paris, most of you, yet, but my great hope for you is that someday you will go, and when you go there you will see the Notre Dame Cathedral, and when you are there you will take pictures. Each of those pictures is taken by a camera, which is the same as a view. You will be pointing at something, so your camera has a position, your target has a position, and you have a lens angle, you have a field of view. Those are the types of things that are stored in a view. We do it by making a box, making a coordinate system, saying plan, defining our view, and then when we eventually go to the viewports, we can make a viewport that is the exact same size. I'm going to hit apply here, OK. I can now turn everything on. I'm saying minus layer, thaw, star, on, star. That gets everything on. So when I go over here to ANSI A, I can start usually by getting rid of my viewport and now make a new one with that, make a viewport, which is vport, vports. I'm going to make a single one, hit OK. Click here, and I might not want that at 7 by 9. I might want it at 9 by 7. I might want it at 4.5, comma 3.5. Now when I say V for view, mark 1, set current, OK, it'll tell me to grab, and you get then the warm fuzzy here of a 1 to 20. So that's a quick one-way through. We'll go through the steps one more time. You draw a box that is similar to what you want your view and viewport to be. Similar, we will look up on Wikipedia. It has the same angles and then the same relative size for each side. I would recommend doing it by squares. You can do odd-shaped viewports, but all you're doing is making AutoCAD work harder and tricking it out. So you make your box, twist it the way you want, make a coordinate system using 3 points, getting used to using point filters when you define that. Once you have made your coordinate system, you say plan. You then define your view, keeping the clicky clicks off. You finish out the view command. You can go back to the standard world coordinate system. Then when you go into your paper or your layout tab, you will be able to then make a viewport to a similar size to what you did in your view. You then put the two together and you get the warm fuzzy of knowing exactly the scale you wanted. We will work with the annotation issues on this. I will guarantee you that views is something that is very key in all of graphic arts and all of cinematography and all of visualization. When we start dealing with camera paths and the like, you will see the camera paths are just a series of views. We have cameras all over campus, and so the reality is there is all kinds of views being taken throughout the day. We have monitoring software on all kinds of computers, soon on all computers, I would presume. And so there's all kinds of data streams being streamed in. These are all more or less looking at the world from one particular way. A view is a way of looking at the world. We've looked that we can look at the world not only by going to Google Earth or Virtual Earth, but by going also to places like cities and counties and the USDA, if you would. Thanks for listening. This video will be cut down so that it fits on YouTube in HD. I could hit plot here. I could do all kinds of other stuff. But no matter what, no matter where I am, I can hit V and I can see that I have model views, layout views, and I will really, really caution you from using and clicking on the preset views until you know what it's doing with your coordinate system. I know it seems simple. I know it seems like it shouldn't be a problem. Until you have mastered what's going on in your coordinate system, I would have you actually make your own top, bottom, left, right, front, back, and isometric views. Thanks for listening.